Hi, everyone. Nice to see you all here. I'm Rita. I'm part of XGeeks teams. It's always nice to spend my Wednesday evenings with you. So I'm looking forward to this new live stream that we have today. And I need to tell you, this will be a pretty special one. So I hope you enjoy it as much as I will. Before we move to that, again, welcome everyone. Welcome. If you're new to our channel, you know what to do. You need to subscribe our channel, activate your notifications, check the previous talks, and for sure, check this one as well. If it's the first time or the first time that you heard about what XGeeks is, I'll give you a brief overview of that. So XGeeks is an engineering company focused on providing capacity to product companies. We're not a typical project company due to a lot of factors, and we could be here talking all about it throughout the evening, but mainly because we have a huge focus on community, a strong engineering culture, and a product drive. XGeeks represents the balance, or at least what we believe it's the perfect balance between project and product. And our teams are working now across Portugal and Germany in building products while dealing with a broad stack. So if actually proactivity and eagerness to learn, and you also have incredible tech skills, and all of this is part of our DNA, you should check our website out and our social media, because we might be the next stop of your ride. But for today, I need to introduce you to a very special guest, which is Karina Varela, which will be speaking about creating decoupled microservices to deliver business logic in cloud-based architectures. And for that, I'll bring to the stage our dear Karina. Go ahead. Hello, nice to see you here.
Hey Rita, how are you?
I'm doing great. How are you?
I'm doing great too. Thanks for the opportunity. It's a pleasure to be here with the XGeeks team.
Awesome. Thank you for sharing your insights with us. I can anticipate a great talk. I'm pretty sure everyone at home is also feeling the same. So if you don't mind, I'll leave up the stage to you, and I'll add the screen as well. So take the lead. And again, just before we start, if you have any questions for Karina, feel free to leave them in the chat. We'll go through them throughout the presentation or the talk. So we would be happy to have your insights. So feel free to leave them and we'll address them. And having this said, go ahead, Karina, the stage is yours. Thank you.
Thank you, Rita. Hi, everyone. I am Karina Varela, and I am a technical marketing manager at the Red Hat BU team. I work with one of the stacks of products in the middleware team. And today, I am going to talk a little bit more about how you can deliver business logic in cloud-based architecture, because things have changed so much over time that it's important for us to understand how we can actually deliver the things that matter, that is actually our business logic, right? So with that, let's get started. So if you look to the past years, you will see that we had a big change. And if you only need to look to like 12 years ago, you don't even need to go too further, because you will see that the goal line that is super popular today actually started in 2009, followed by the Scrum Guide that was published in 2010 that actually boosted the frequency of the deliveries, the pace that we like to deliver our applications. And this was a boost to the things that were coming next. So you will see that in Oracle was acquired. We had the 2 factors published by Heroku on 2011. And if you look at how it went so quick, on 2011, we already had the first version of Openshift released, which is a platform to help us deliver containerized services. So the Cloud Native Computing Foundation, who is so popular today, was actually founded in 2015. One of the specifications that we are going to talk today was also brought to us by OMG on 2015. The name of this specification is DMN. And as all of this happened, the applications and the way that we deliver application had to change, right? So with this, cloud became more popular. And when we are talking about cloud, we actually have different ways to deliver on the cloud. We can deliver on a, let's say, private cloud, public cloud, hybrid cloud. We can choose different sets of services that we want to delegate the management, configuration, and backup, for example, to other companies. So you can delegate the infrastructure, you can delegate the platform that will manage your containers, you can delegate everything. You just want to code, and then you can provide the code only, and the code only to be deployed, and all the platform will be managed by someone else. So there are several different ways to deploy on the cloud today. For our talk today, we are going to see a little bit of a deployment strategy using CaaS, where we have a container as a service. So we have a container orchestrator that is provisioned on AWS running one of our workloads. And we will also work with managed Kafka, managed event streaming. So I didn't even, you will see how easy it is for the developer to interact with event streaming without worrying about none of the installation, none of the configuration. It's super trivial. So I want to do a mix of these things to show you how it works. When we are talking about deploying on the cloud, we need to think about different, we need to look to our applications from a different perspective. We need to create applications that are what we call today cloud native. And that means that this application can take advantage of the several resources that we have on the cloud environment. It needs to be lightweight. It can run on containers, take advantage, for example, of service meshes, and many other things. This description here is a concept brought by the Cloud Native Computing Foundation, but it is and one of the most popular concepts too, but it's not a concept that is already recognized by everyone as a single statement, you know? So still, we have an agreement. We need to create something that is lightweight, that will help us not increasing the costs. Quite the opposite, reducing the costs, okay? At the same time, from an architect or a senior developer perspective, or a project manager, from the PO, for example, the product owner, you might need to look at the trends to know how you're going to deploy your applications. This trend, published by Gartner, brings two key things that we are going to cover today. The distributed cloud environment that brings us location independence, and also the intelligent composable business, which allows us to not only decompose the code itself, but the business. So by separating our business logic, we can separate the teams that work on that business logic, and even get these people working on this business logic themselves, like the business analyst or the business expert himself. It doesn't need to be, for example, the developer coding it. In order to do that, we can take advantage of different options out there in the market, different specification options that allows us to implement business rules in a more visual way, or that has a way for us to implement rules that will be parsed by a super powerful engine. We can develop our processes and execute them in a cloud native way, and also do mathematical optimization with resource planning in order to reduce our costs. So let's get to what matters, okay? Let's talk today about decisioning. So we are talking about DMN, decision modeling notation. DMN is a way that we can write our business logic, our business rules, following any specification. So that takes out vendor lock-in. As long as you are working with DMN, you can work with any tool that supports DMN specification. And it is also very visible, very easy to understand, not only for developers, but also for business users. Let's take a look at an example. This is a kind of, let's say, this brings a more advanced element, which is the the service node. But still, let's take a look here. So what do I have, Karina? You're showing me a diagram, nice, but what does that mean? So let's say I wanted to decide, my business logic is to decide if I should suspend a driver or not. And in order to suspend them, I need to define if the total points that he already has is higher or equal to 10, okay? So depending on this logic, and this here, this way that this code is written, it's called feel, friendly enough expression language, which is also part of the specification. That is pretty readable, okay? So this is our decision node. But in order to make this decision, I need the inputs. So I need to know information about the driver, and I need to know information about the violation that he committed, he or she. This can be defined as data types. So you'll see, for example, the violation has a code, has a type, a speed limit, actual speed, and all of these are going to be the inputs for the service. And based on these inputs, the service can make the decision, okay? So this is another decision node, just like this one. So in order to calculate the fine, this node will use the violation type, the violation actual speed, and will define the output, where every line is a rule. So for example, if I have a speed in between 10 and 30, the fine applied will be, I will need to charge like $500 and give 3 points to this person. So I'm adding 3 points. This decision will use the driver information and the result of this decision. So you can see that we are composing our business logic, and we can even reuse it across different models, different services. Good. But Karina, you were showing me a Java project. What is this, right? Because they were, I don't know, just open a diagram. Yeah. So let's talk a little bit more about this. Hello, Max, Andre. I'm following the chat, okay? So you can see that I am using VS Code. And in order to visualize this file, which is actually an XML, I am using an extension to parse not only DMN, but also BPMN and test scenarios. But today we are focusing on decisions, so we'll stay with the DMN, okay? So that's how I can open it on my IDE. Another thing is that there are no classes here. This is a Quarkus project. So this project is based on Quarkus. Let's talk about it in a moment. And there are no classes here. So how's this going to work? Let's see in a second. Things that has changed. We went to microservices architecture. It's becoming a trend. It's not a silver bullet, but we do know there are use cases for it. And when we start working with microservices, we will see that we'll have more and more independent services involved in the same business flow. For example, if I have 4 services that need to interact with each other, will I do like endpoint to endpoint communication? Is that the right thing to do? It depends. We might have orchestration scenarios where we have a centralized component to invoke each service, and we might have event-driven scenario. What is the event-driven scenario? It is when we have a broker, someone responsible for routing the events, and every service is going to be either a consumer or a producer of events. Let's say I got a new request, a new order in my website that produces an event that goes to the event router to a specific topic. Let's say the new orders topic, okay? Whichever service that is listening to this topic is going to react to this event. Karina, why are you talking about events? because our demo is going to include events, because we're talking about event-driven architectures today and how we can use our decisions on it. So each service can either subscribe to a topic to react to events, or publish to topics to let the ecosystem know what happened with the processing of that event. When we mix all these concepts, we can get to the event-driven decisioning. And how do we do it? We can do it with tools that support the automation of our business. One of these tools that was, and this is a pretty cool tool, is Cogito. One of these tools is Cogito. Cogito is based on battle-tested tools like Druze, JBPM, and Optoplanner. And it was created to run in this new scenario where we have cloud-native requirements, serverless requirements, super lightweight execution with Quarkus, for example, or we want to have a focus on developers. So it's a different generation of tool to help you automate your business. It relies on, it can be deployed with runtimes like Quarkus or Spring Boot. It can integrate with KNative to deploy in a serverless manner. InfiniSpan for persistence instead of a traditional database. And we have several other things that we will see here. So how does it work? Karina, are you talking about a centralized thing that I need to invoke? And not necessarily. When we are talking about decoupling our decisions, you will create an application that has your business logic. You are choosing the way to implement your business logic. And the way you implement it can be with VMN, can be with DRLs, for those who knows Druze. It can be in different ways, right? So what you get when you choose Cogito is that you have support for the several ways of implementing business logic and running it in a performant way. So when we have a Cogito application, we will just have another service running in the ecosystem. That can be, for example, Openshift or Kubernetes. In this service, we will have a domain API. So you're not going to invoke, for example, fire my rules. It will automatically abstract which endpoints to create, the REST endpoints, for example, based on the logic. So if I am validating if the driver should be suspended, if I have a traffic violation DMN, I will get automatically generated for me a traffic violation REST endpoint, because Cogito can understand the data inputs and can understand the nodes to be parsed and create all of that for us. It also has, it also can run with JVM or native mode, and we will also see this in action. Okay, so cool, Karina. Yeah, but what else? What else do we got? So before we go to the next step, let's take a quick look here. This project, like I told you, doesn't have any Java class. It is a simple project that has a DMN file and the extensions for Cogito. So we have the event-driven add-on, because I am going to connect this application to Kafka in a second. And the, oh yeah, that's it. And the Quarkus add-on, that's it. That's all we need. So nice. With that, I can already use it with all the goodness that you already know from Quarkus, hot reload, all those things. But I'm here to talk about something cooler than that. So I'm not going to explore those bits today because of the time, but we can talk about it in another session if needed. But for now, we know that we can compile Quarkus applications to run with JVM mode or native. So here, what I have is, let me put my, okay, you can see my terminal now. I am now in the folder of the same project that I just showed you, okay? And I have already compiled it just to save some time. So if I start this application, hey, thank you, Mario. So when I start this application, what is going to happen? This application is bootstrapping, and it's taking a while because it's already connecting to Kafka. Kafka, but we are talking about decisions. Yeah, Kafka. Let's see how it goes. Let me share my screen with you. So before looking into Kafka, look, I just started the project and it has all the APIs for me. See? So I have, for example, the traffic violation get and post. I have the post. The post means that I want to execute, to validate the decision. So I can validate the whole DMN. I can validate specific nodes, decision nodes on my diagram. It's all automatically generated. So here, if I open, for example, the traffic violation, and I choose to try it out, let me grab something that is already there. As you see, Cogito can already infer the type of input that we expect. So that makes things way easier. So I have an example here. If I have, for example, a driver of 25 years old that has already 13 points, had this speed limit violation, and the actual speed was this one. So when I click on execute, it will go into the engine, run the decision execution using the decision engine of Cogito that is embedded in this microservice that is running with Quarkus. Did you follow? When I click on the execute button, it will go to the microservice that is running with Quarkus. It includes a decision engine that comes from Cogito, okay? So once I execute it, I have problems with invisible characters here. So let me do this the other way around. So I have a driver. I hate when this happens. It's just my edit.
Don't worry, Karina. That's why I'm here. So, guys, if you have any question, please let us know because that's the moment, the perfect time to fire a question right now. So I can see Mario, Maximilian, the guy who goes away in the fly.
We are good. We are good. So I just
Okay.
fixed just invisible chars. Thank
Let
you,
make
Otávio.
me be visible.
Thank you. It's just my editor. It always put invisible chars on my text. I hate when that happens, but here we are. So when I execute it, we will get the response saying that this driver should not be suspended. Okay? It will bring the result of the execution. And yeah, so with that, we see the basics. So you can get started with one command in your command line. You can create a new project using Maven archetype. You can start it using Maven Quarkus dev mode, and you already get this. Okay, so this is the basics, but we want to go a step further. So services can interact by invoking each other via REST, for example, but they can also interact through the events. Events, the eventing happens, like I told you, through topics. So this application here is configured to publish to a topic here. So we have the small messaging extension So this means that in my application, I have Quarkus. As I have Quarkus, I start adding my pieces of the puzzle to complete my goal. In order to talk to Kafka, I need an extension that can talk to Kafka. One of the available extensions is the small RAI messaging, and it actually follows the microprofile specification. So it's just I love things that follow specs, because then it's vendor. We don't have vendor lock-in. So okay, here it's just small RAI, and then I define that I have a the channel, and I say that this is the topic. So for my channel, my outgoing channel, I want this to be the name of the topic that I will publish my results of my execution. Or I want to receive the inputs. So notice that here I have sent an input, okay? So what if this input came through an event, and this event is actually being heard by this service? And this service is going to post the result to any other application that is interested on this result to this topic, okay? So nice. So one thing, just a quick highlight, there is a new specification, not new, but it's new compared to the existing time of other things, but it's called the Cloud Event Specification. This tries to create a pattern on the way that applications talk to each other using events. So it brings a pattern on the description itself. Okay, you can take a look at it later. But here we are working with cloud events. So in order to get this result in my service through Kafka, I am going to post it to Kafka using the cloud events format. So let's take a look here. Let me finish this. If you never worked with Kafka, let me tell you a trick. You can use a CLI to help you post messages to a topic or consume messages from a topic, okay? So let me start consuming messages from the topic DMN event-driven responses. And I will also start producing messages to the request topic, okay? So now my local client has connected to the broker, which we'll talk about later. And I am going to send the input. Let me grab it here. Karina, oh my God. Yeah, it's just because it's one-liner JSON, but what do we see? The version of the cloud event specification. The idea of this request, where is it coming from? So I could, for example, name my service here so that we can actually track everything that is going on in the broker. This is a decision request, and I have the model name and the DMN namespace. So this is what actually links the event to this specific decision, okay? Okay, good. Here's my data. I have the driver age, the points, and the violation. Once I post it, this service here that is listening to the topic has listened to the topic and post the result back to the responses topic. So as you see here, my driver should not be suspended. Karina, where is this coming from? Should the driver be suspended? Here, remember, on our DMN file, I have a decision node. Should the driver be suspended? See? So things, here we are using an ubiquitous language, and it's all like automatically generated for you. So that is super time saving for developers. Karina, you were talking about that, okay, but what about if I want to deploy it to the cloud, to a cloud environment? Because you're running it locally. I am. If you want to deploy it to the cloud, I am here running an Openshift in Amazon. Openshift is an open source flavor of Kubernetes that brings other accelerators to it, other plugins, and it tries to wrap some of the complex features to make things even easier. So it also has the support for operators. So I'm using OpenShift 4 here, and I have installed 2 operators, one for Cogito and one for KNative. The one for Cogito allows me to deploy my application directly from source code, for example, or from a binary build. I can have my image deployed on Quay. I can have it on my local machine and just push the jar to it. So there are different ways that we can deploy it. So it allows me to define how I am going to build my application and how I'm going to run it. Okay. If you want to make your life easier, you can use the Cogito CLI, and with one command, you can create the decision service. So here, let me stop this. So here is the exact command that I ran to deploy it. Using the Cogito CLI, I just told Cogito, I want to deploy a new service. The name of this service should be this, and I want you to grab the source code from here. Okay, so this is the GitHub where the project is. Based on the code, it will understand that it's Quarkus, which Java version to use, the image that it needs to use. It knows it will do everything that it needs to do. And then I have some environment variables. These environment variables are actually a way that we can have our service parameterized. We can parameterize options to our service. So where is my Kafka running? My Kafka is running somewhere. My application doesn't need to know. So we can use one of the best practices described by 12-factor that is externalizing our configurations, okay? So you will see these environment variables here configured. And these are the same that I'm passing over to OpenShift. So I'm saying, this is my Kafka server, this is my client ID, my secret, and etc. Okay? Once I deploy it, it creates the build and the runtime. But look, I don't have anything running yet. So I have 0 pods, okay? 0 pods. Because I wanted to show you that this is a live demo that is not recorded. So let's clean the outputs here, and let me send again a decision to be evaluated. There's nothing being evaluated because I already stopped my application on my local environment that was listening to it, okay? So let me see something here. Invalid data, why? Let me send again. Here, okay, so good. So now let me start this application. The operator has already grabbed the source in GitHub. It has a builder image, so it uses the best practices to create the image that will be used for the execution so that it can be as lightweight as possible. So it has built the image, created it, put it into the Kubernetes registry. So now I can just run it. I have set scaled my application to 0 just because of this session, and I will now scale it to 1. Okay, this is using the JVM mode. So once I scale it to 1, I can see that I have my application here running, and we can check the logs to see what is going on. It is starting just like on my local environment. And as it gets started, it will already parse the messages that were there waiting on the topic. So even if the server goes down, in the moment that the application comes up, it can grab the events on the topic and process it. Okay? Cool. But like this is JVM, I still want to see something more. Hold yourself. Let's go for it. So before we talk about native, let's understand what is this Kafka environment that I'm using, okay? If you go to this link that my friend will post here on the chat for you, Red Hat /strike Kafka, you will be redirected to this managed offering where you can create a new Kafka instance. So I have created one here. It's super quick. You can have a Kafka running in like 5 minutes without the need to open any terminal, install anything, just fill in the information like the name of the cluster, your user. You need a Red Hat developer's account, but you don't need to put the credit card. You don't need a credit card, okay? So it's free. You can try it as much as you want. And with the service, you can actually have this running for, I think, 2 days. This is currently on development preview. And I have created my cluster here. And when you create it, this is exactly the same page you will see, okay? So you will see this, and you will have the ID and etc., including the connection details. With the connection details, you can connect using the Kafka CLI client, like I showed you. You can connect using a Quarkus, Spring Boot, whatever that needs to connect to Kafka, okay? That has I think I'm back now. Okay, so I give a little freeze. Okay, good. So let's move on. With the Bootstrap server, this is the address to our Kafka broker. If you run it locally, it will be like localhost 9092. That's the same thing we're talking about, you know? Here it's ending with 443 because it's under HTTPS, TLS, okay? And in order to connect to it, you need an authentication method. So you have the token endpoint, and you have to create a service account, which is nothing more than a user and a password for you to use. So if I go, for example, to the service account, I cannot, let me see if I still have one here to show. Let's mix test. I think I've reached, okay, so this is what you see. It's just literally like a user and password, okay? But once you copy and close, you cannot see this again, so make sure that you save it, because this is the same things that you use to connect to Kafka. So remember that I showed you all the environment variables. Here they are, exactly the things that I've just showed you. Address for the Kafka broker, client ID, secret ID, and a auth token. That's in there. So that's all I had to do to create my Kafka environment and to connect to it. Okay, so it's as easy as that. Awesome. With that, we can move on to the next part. So a little bit about managed Kafka. Already spoke about it. So let me drink some tea. Breathe. Let's go. Still, I know you want more because you can never be satisfied with what you got, right? You still want to talk about serverless. You want to talk about scaling down to zero whenever you're not using a service. And when you need it, so what is the big thing in here? When we are running something, in a serverless mode, we need it to be ephemeral, and we expect a single action on top of that service. Doesn't it sound exactly like what I've just done here? I have a stateless service that expects an input, will parse it, and that's it. It's done. It's processed. I don't need to have this running anymore. So why would I need it there, right? So this is an example of a scenario for you to use a serverless. And we can use, along with Kubernetes, KNative, which is it brings a set of building blocks to create serverless applications. It has different components like the KNative serving, KNative eventing, and more, I think, KNative messaging or something like that too. But the thing is the ability to scale down to 0. And that's what we are going to see right now, okay? And I'm not sure if that's going to work because I think I deleted it. Let's see. So what does it mean to scale down to 0? When running on Kubernetes, your containers are running on pods, and these pods, the number of pods that we are going to run actually depends on our configuration, on the load, so we can scale up if you have more load. But what if you don't have any load? Maybe you could scale it down to 0 and only start a pod if needed, if any specific thing happens on the ecosystem. So with KNative, we can actually make that happen. For decisions too, okay? So what will we see now? Are you paying attention? I think you are. What will we see now? Event-driven decision with Cogito. We've already seen this. Running with supersonic, subatomic Quarkus, which will allow us to compile our service to native mode, which then enable us to run it with KNative in a serverless mode. Okay. So let me see if I have that still here, because I think I have deleted it. Deployments. Oh no, it's here. So what did I do? What did I do to deploy this? Is it hard? Oh my God. No. So in order to make things quicker, so that I don't have the Openshift environment pulling down the code, running Maven build, for demo purposes, I just have put my compiled application. So I did Quarkus. Yes. So when you want to compile application with Quarkus, you can just paste in the tag native. But when you compile with native, you are going to create a native of your operational system. So if I run it on my machine, it will create a native to run an executable file to run on Mac. Okay, it would not run on Linux, and containers run on Linux. So I wanted it to run with Linux. In order to do that, you only need to pass in this tag, the Quarkus native container build, and it's going to build your native file inside an image. So it's going to start an image with Docker, build it up, blah, blah, blah. And then you get it in your target folder. Then I have my Docker file. So complex. Yeah. So basically, it puts my runner file inside a Cogito runtime native image that is based on, I think I need to confirm if it's running with Mandrel or Graal. I'm not sure. Got to check the latest version. But that's all. That's all I did. Then I put it in Quay. Okay. So Quay is just an image registry. So there is my image. Okay. With this image, I can just say, hey, KNative, create a new service with this name using this image. So that's what it did. And it created the a new deployment, okay? In order to do this, I had the operator installed. So the operator took care of everything. Okay, so it's now on 0. Karina, you told me it was deployed. It is, and I think it is working. Let's take a look. So let me open again my terminal. Then let me put this like this, my terminal here. Okay, so I am running a watch command that is checking the pod's execution on this namespace. Just checking like the pods every 1 second. Okay, so I have here, I don't have any pods actually. So let's create a pod. So I'm going to open Postman just for the first request, then I will show you more things, okay? Just so we can see it running. So what will I invoke? I'm going to request the execution of the same decision using REST, okay? I think I deleted it. I don't see it here. Let's see, if it doesn't work, then I will deploy it, okay? Really quick, it's really quick. So let me execute the request. Let me see. Here it is. It is deploying already. Scaled up to 2. And if we check their deployments, we can actually see here that it's running. And I got my response. So let's see here. Where did I think this is just, I can't find my response. Okay, body. Okay, good. So what is my response? Well, the driver should not be suspended. But what if I say that he already has 19 points? Remember that our decision is made, the driver will be suspended over 10 points. Okay, 20 points. So let me put like 19 already because he will get a fine. And this point, he should be suspended now. So now he should be suspended. As you see, we have a huge flexibility to either run with serverless, use orchestration, use endpoint to endpoint communication invoking REST. You can use event-driven decisioning if you connect your service to Kafka. You can use the hybrid cloud by having your service deployed using source to image, using binary build that comes from an image. You can have it connected to a Kafka broker that is running in another cluster somewhere managed by someone that in this case was Red Hat. So all this flexibility for developer and the architect who's making the decision is actually the key to create great applications for the cloud environments. So knowing that all of this comes from the single choice of having, for example, Quarkus that brings all the goodness of the ecosystem that is backed by Red Hat is a great tool set for the technical person. So I hope you enjoyed the presentation. That's all I got. I don't see any questions on the chat, so I would like to appreciate the opportunity, Otávio.
Okay, that's my pleasure. Oh, hello, Porcelli. How are you? Yeah, that was an amazing presentation. Guys, I'm gonna give you a couple minutes, a couple seconds. If you have any question, that's time to say. Otherwise, just say congratulations because it was an amazing presentation. Congratulations again, Karina.
Thank you. It is a pleasure to be here with the XGeeks team again and with all of you who are watching. And if you're watching this later and you have questions, feel free to reach out. This is my Twitter.
If you're not watching now, sorry, you're too late.
Oh my God. He's just kidding. So here's my Twitter. The key community is really active. So Otávio, can you please share this link here with them? So in this website, You can see the projects that I've mentioned about. You can see the link to more content on YouTube. You can see the link to the Zulip chat, which is like a place, a public open place where all the engineers are. Many people from the community will see, like, there's so many interesting and knowledgeable people there that it's worth talking to them if you wanna know anything
Okay.
that I didn't mention about. Okay.
Okay, thank you, Karina. Again, that was an amazing presentation. Guys, please follow her on Twitter. So she's amazing. She knows a lot about cloud native, where nobody knows exactly what does that mean, but she knows exactly what is that. And also Cogito. And yes, thank you, Karina, again, and see you around.
Okay. See you. Bye bye.